Okay, now we're going to do another one, and this one is going to be a combination circuit. And basically we have 4 different resistors. I'm going to go from smallest to largest because that'll just be the best, I think. 6, whoops, got to get my pen to work here. 6 ohms, 9 ohms, 12 ohms, and 18 ohms. And I want to find the voltage, the potential difference across each one, and the current through each one. So we have a 30-volt battery, and as this current moves from positive to the negative pole of the battery, it encounters these 3 first, splits up into I1, I2, and I3, comes back together again as I here, I total, goes through the 12 and then back, all right? So our basic equation is V equals IR, and then 1 over, 1 over REQ equals 1 over, I'm going to put the numbers down here, the R1 plus 1 over R2 plus 1 over R3, and REQ in this case 1 divided by 18 plus 1 divided by 9 plus 1 divided by 6. X to the negative 1 gives me 3. So I get 3 ohms from that one. And that's 1. And then I get 1, or not 1 over, sorry. For series, it's going to be REQ equals R1 plus R2. I only have 2. And I'll show you what I mean by that. So I'm going to redraw here. Here's the battery, 30 volts. This is plus, that's minus. I'm going to come here, and these 3 parallel are the same as a 3 ohm resistor. I just figured that out right here. All right, so I'm just substituting that. I still have my 12 ohm. And then it's going to come back up to the negative side. Okay. Well, what do I do with those two? I just add them together. 12 plus 3 gives me 15. So my total resistance in this whole thing is 15 ohms. Therefore, my total current is V over R, which is going to be 30 volts over 15 ohms. And of course, that's going to give us 2 amps. Now, here's where we have to look at what we know for sure. We know for sure that the current is the same through series. That means there's 12 amps through the 3 ohm and 12 amps through the 12 ohm. So I can go up here, the 12 ohm is an original resistor in my table. 3 ohms represents the 6, the 9, and 18, so I'm not ready to do something with it yet. But the 12 ohm has 12 amps running through it. Now, V, anytime in this table you know 2 of the tables, 2 of the cells, you know the third because we have this equation right here. So I equals, or not I, V equals I times R, so 12 times 12 is 144. And so I have, whoa, sorry. Okay, I messed up. Boy, not 12 amps, sorry, 2 amps. Boy, 12 amps is a lot. 2 amps. Let me go up here and erase this 12. I knew something was wrong when I saw, there we go. So 2 times 12 is 24 is what I was going to say, but then I was like 12 times 12 is not 24. So 24 volts. Now, a lot of the voltage, most of the voltage is going to be across the 12 ohm resistor. So how do I find the other parts information? In other words, how do I find the current, the voltage through these? Well, I know these 2 numbers right here are correct. That is R and I. So V, the voltage, the potential difference across this 3 ohm resistor, which represents the 18, the 9, and the 6, equals 2 amps, I times R, times 3 ohms, which equals 6 volts. Well, guess what? 6 volts is across 18, which is across 9, which is across 6, because all three of these are parallel, and there's 6 volts across the 3 ohm that represents them, so the rest of these are all going to be 6 volts. And 6 plus 24 is 30. That gives us our original voltage. That's good. Now, the current through each one of those is going to be V over individual R's. So 6 volts divided by 6, and 6 volts divided by 9, and 6 volts divided by 18. So we have 1 amp, 6 divided by 9, 0.67 amps, and then 6 divided by 18, it is 0.33 amps. Now if I add 1 plus 0.33 plus 0.667, I get 2, because the 2 amp, see this is 2 amps here, the 2 amp, the current here is 2 amps, so when it hits here it splits up into 0.33, 0.67, and 1, and then it comes back together to give me 2, which goes through the 12. So the three, I'm going to circle these in a different color. The 3 currents through the parallels have to add up to give the total current, and the total current is 2, which is traveling through the 12 ohm resistor. And that's how you do one like that. A little bit more complicated, but it's not hard once you learn how to do it. So just practice and learn.